You probably understand how to solve radical expressions that are perfect squares or perfect cubes. If not, check out my earlier 2 videos on the topic. But what if you have a radical expression that is not a perfect square or perfect cube? How do you go about solving these expressions? In this video, I'm going to show you how to solve those kinds of expressions. Before we get started, let's do a bit of a refresher of what radicals are if you're not sure what a radical is. Radical expressions are characterized by a radical sign, like the one you see here, and an index. The letter N is representing the index in this example. It's a small number written in front of the radical sign, indicating whether you have a cube root, a fourth root, or any other type of root. When no number is written in front of the radical sign, you assume it's the square root. Let's look at a few problems. Let's simplify the radical expression, the square root of 32. The square root of 32 is not a perfect square. So, in order to solve this problem, we're going to find the perfect square factor of this problem. I know 16 goes into 32 twice and is a perfect square. So I rewrite the expression as the square root of 16 times the square root of 2. Now I can simplify the square root of 16, which is 4. And simplify the square root of 2, which cannot be simplified further because the square root of 2 is not a perfect square. So 2 will remain under the radical sign. Our answer is 4 times the square root of 2, with 4 written in front of the square root of 2. Let's find the square root of 640. Just like in the last example, in order to solve this problem, we're going to find the perfect square factor . 64 goes into 640 10 times and is a perfect square. I rewrite the expression as the square root of 64 times the square root of 10. Now I simplify the square root of 64, which is 8, and simplify the square root of 10, which cannot be simplified further. So 10 will remain under the radical sign. Our answer is 8 times the square root of 10, with 8 written in front of the square root of 10. Let's simplify these two radical expressions, the square root of 50 plus the square root of 72. In this problem, we are adding two radical expressions. Don't let that confuse you. It's the exact same process. Let's take the square root of 50 first. I know 25 goes into 50 twice and is a perfect square. So I write that expression as the square root of 25 times the square root of 2. Let's take the square root of 72 now. I know 36 goes into 72 twice and is a perfect square. So I rewrite that expression as the square root of 36 times the square root of 2. Now we can simplify each expression. Let's start with the first expression, the square root of 25 times the square root of 2. When we simplify the square root of 25, we get 5. And when we simplify the square root of 2, we cannot simplify that expression any further. Now, let's simplify the second expression, the square root of 36 times the square root of 2. The square root of 36 equals 6, and the square root of 2 cannot be simplified further. Now we have the radical expressions 5 times the square root of 2 plus 6 times the square root of 2. We need to add these radical expressions by adding the multipliers 5 and 6. When we add our multipliers 5 and 6, we get our answer, 11 times the square root of 2. Let's look at one more problem. Let's simplify the radical expression, the square root of 80 minus the square root of 125. In this problem, we are subtracting two radical expressions. Again, don't let that confuse you. It's the same process. Let's take the square root of 80. I know 16 goes into 80 5 times, and it is a perfect square. So I write that expression as the square root of 16 times the square root of 5. Let's take the square root of 125. I know 25 goes into 125 5 times and is a perfect square. So I write that expression as the square root of 25 times the square root of 5. Now we can simplify each expression. Let's start with the first expression, the square root of 16 times the square root of 5. The square root of 16 will simplify to 4, and the square root of 5 cannot be simplified further. Now let's simplify the second expression, the square root of 25 times the square root of 5. The square root of 25 equals 5, and the square root of 5 cannot be simplified further. So we'll leave that expression as it is. Now we have the expressions 4 times the square root of 5 minus 5 times the square root of 5. We need to add these radical expressions by subtracting the multipliers 4 and 5. When we subtract the multipliers 4 and 5, we get our answer, the negative square root of 5. As a side note, whenever you have a negative sign or no sign in front of a radical sign, it's assumed that the number 1 is the multiplier. If you found this video helpful, like the video and subscribe to the channel. And remember, algebra is simple when you start with the basics.